So earlier today we heard about the evolutions or the social evolution of language, and to a certain extent we heard about the emergence and the evolution of zero. We even heard about our current economic affairs and such. And I'm going to kind of talk about all these things, and in particular continue the evolutionary theme and talk about the evolution of cooperation in society and elsewhere. So we've all come across ideas of the greater good, altruism, cooperation, or the sacrifice of an individual for the greater good of others. In biology, we have an analogous concept where we look at the willingness of certain individuals to give up some of their reproductive potential to increase the reproductive potential of others. Now, this paradoxical concept in the social sciences is grappled with by philosophers, sociologists, and political scientists. And in the biological concept, it's obviously an important question for biologists. Now, the question really becomes as to how and why does this cooperation emerge? Now, we're going to look at it at first from the biological point of view, then connect to the social sciences, and kind of connect it to everything else. So currently, biology is really shaped by Darwin and Wallace and their theory of evolution by natural selection. It's a unifying theme and tying of modern biology. Now, the interesting question in this biology is it's an explicitly competitive framework. Organisms compete against other organisms for their reproduction. And the question becomes, how does cooperation emerge in such a competitive environment? We know this cooperation does emerge because it's essential for all the complexity we see. It's essential for single cells coming together into multicellular organisms, for things like ant colonies emerging, or for even human society. So the idea is that we want to study this and answer these questions, or at least try to answer these questions, and that's what we'll kind of do in the next 10 minutes. In particular, we'll look as to how can we create a competitive environment in a more mathematical framework. And from here, we borrow from game theory, the idea of prisoner's dilemma, or in my case, I prefer the knitter's dilemma. Now, in the knitter's dilemma, there is two players. One of them is Alice. Alice produces yarn, but she doesn't have any needles, and she wants to sew a sweater. In the society where she lives, sewing sweaters is frowned upon, so she can't go and ask for needles publicly. Bob, on the other hand, who's on the vertical there, produces needles, but does not produce yarn. He also wants to sew a sweater. So they decide, okay, let's go out into the woods, late at night, bring briefcases with our respective goods, and trade. Now Alice has a dilemma. Should she include yarn in her briefcase, signified by the green briefcase, or should she not, signified by the red? Now, if Bob includes needles, and Alice includes yarn, she gets the benefit B of being able to go home afterwards and make a sweater, but she does pay a small cost C for giving away some of her yarn. Alternatively, if Bob brings needles, but she's tricky and doesn't bring her yarn, then she gets all the benefit of going home and making a sweater without paying even the marginal cost of having to give away some of her yarn. Alternatively, if Bob brings an empty briefcase and Alice brings yarn as she said she would, then she pays the small cost of giving her yarn away without any of the benefit of being able to make a sweater. Alternatively, if she also brings an empty briefcase, then they just met in the middle of the night and traded empty briefcases, and everybody goes back to the same payout. So it seems no matter what Bob does, it's better for Alice to bring an empty briefcase, what we call defection, than to cooperate by bringing a full briefcase. And this kind of sets up the basic idea of a competitive environment. The rational strategy, or the Nash equilibria of this game, is for both individuals to defect and bring empty briefcases. However, from outside the game, we can see that if they both do what they said they would and cooperate, they're both better off. And that's captured by the proto-optimum in green. Now, of course, as mentioned earlier by Andy, we can't always expect people to be rational and conclude all these decisions based on reasoning. So evolutionary game theory comes from a perspective of modeling these as basic agents that have a trait which they pass down to their offspring, which in this case is represented by green circles are ones that cooperate and red circles are ones that don't. And the most standard model will pair them off randomly. They'll play the game, so we can see a green and a green, two cooperators. They both went home and made a sweater. two reds both went empty-handed. Then we disseminate them back through the population and let them reproduce according to how the game affected their growth potential. Higher for people who received a bit large benefit, and a lower chance to reproduce for people who only paid a cost. And then we cycle this for a while. And what we observe is that usually we see more and more red emerging. All the green cooperation starts to go away. And this kind of captures the basic intuition of a competitive environment breeds defection. Now, of course, you and I can think of some ways to overcome this. And evolutionary game theorists have also been there and thought of it. And they thought of three models as to how to avoid it. One is kin selection. Bob's actually your uncle, and you're willing to work with him. So you'll bring the yarn as you said you would. Alternatively, you've encountered Bob many times before, and he's always included needles in his briefcase. So you're much more willing to work with him. That's the idea of direct reciprocity. So you'll include yarn. Or indirect reciprocity. You've heard that Bob is an honest man that always, brings needles as he says he will. So you're much more likely to cooperate with him. And that's the idea of indirect reciprocity. Now, all these things seem pretty simple to us. But if we're an amoeba floating around in some soup, it's not quite as obvious that we can do any of these things. Recognizing kin, remembering previous interactions, or constructing social constructs like reputation becomes very difficult. So I look at the more primitive methods, such as spatial reciprocity or viscosity. Now, before, I think Paul mentioned that if we have a very turbulent environment, it becomes very hard for us to live. So this is the idea we introduce some structure into our environment. We now populate all our agents inside a small grid where they can interact with their neighbors and reproduce into neighboring squares. Alternatively, we can borrow an idea from the selfish gene approach to evolution called the Greenbeard effect, introduced by Hamilton and Dawkins, which is basically a gene that produces three phenotypical effects. One, it produces an arbitrary marker, which we call the beard, or in this case, it'll actually be circles and squares. Two, it allows you to recognize this trait in others, not their strategy, just the trait. And three, it allows you to change your strategy depending on what trait you observe. So, as before, you can cooperate or defect with other circles, or if you meet a square, you can also choose to cooperate or defect. Thus, you have four possible strategies. In human culture, the idea of cooperating with those that are like you, i.e. other circles, and defecting against those that are squares is the idea of ethnocentrism. So here we kind of bring back the social context a little bit of looking at a simple model of human evolution as well. So then, of course, we can combine the two models. We can put our little circles and squares of different colors inside a grid and see how they will evolve with time. And the results we observe are that we do see cooperation emerge, but sadly, it's an ethnocentric sort of cooperation. And here we can see from these graphs sort of, in your blue model, you have the agents who can distinguish between circles and squares living inside a spatial lattice. And the higher up you are in the graph, the more cooperation is happening, so the better it is. And then alternatively, in the red and the yellow, you can see models where there is no spatial structure or where there is no effect of being able to recognize people based on if they're a circle or a square. So it kind of gets a suggestion of how evolution could have shaped the way we are today, and how evolution could have shaped the common trend of ethnocentrism in humans. Now, the model doesn't propose ways to overcome ethnocentrism, but one thing it does is at least it creates cooperation among the scientists who use this model. In particular, the amount of different fields that use this model. We have sociologists model for peace building and conflict resolution, or in this case, cooperation would be working towards peace, and defection might be sending a mortar around to a neighboring village. Psychologists who look at games like the prisoner's dilemma or the knitter's dilemma in my case, and say, well, humans tend to cooperate in certain settings. Why is that? Can we find evolutionary backing for that? So the previous example of looking at ethnocentrism is an example of this. We can look at biologists who look at how the first molecules came together to form life, or how single cells came together to form multicellular organisms, or even in cancer research and the spread of infectious disease, such as the swine flu. Even chemists and physicists use this as a model of self-organizing behavior and a toy model of nonlinear dynamics. And of course, it comes back to computer scientists and mathematicians, who also use this to study ideas like network structure and distributed computing. Now, the reason all these fields can be unified by an idea, this mathematical idea underlying evolution, seems kind of strange. But the reason this can happen is because of the simple nature of evolution. Evolution can occur in any system where information is copied in a noisy environment. And thus, all these fields can cooperate together in working on finding answers to the emergence and evolution of cooperation. And hopefully, starting with the sciences working together on these questions, we can hopefully get even people around the world to also cooperate. Thank you.